Hi there, this is Renee Rubocava with AutoNet, and today I want to talk a little bit about an interesting topic that came up on GeoNet about working with geometries. So the idea here on GeoNet was the author is asking, can you go ahead and extract the intersecting points from lines that intersect? So he's got a good diagram here kind of showing what he expects to see. So we have these blue lines here intersecting with these highlighted green lines here. And you essentially just want to grab the intersecting points off of those lines and extract those from the data. That seems like a pretty straightforward task, and it's something that if you worked in desktop, you may have wanted to do before. Like maybe you want to get the intersections of streets or the intersections of sewer lines to streets, utilities to streets, that kind of thing. You might want to just kind of pull those points out. And I know I've done this before in the past, and I'll show you how you could do that with desktop in a second here. But if you go ahead and you want to try and do this in the JavaScript API, there's a couple of things you can do. So first off, the question pertained to using Geometry Engine to do it. So Geometry Engine has a method called intersects, plural, intersect, which basically tell you if two geometries do intersect. And it just returns a Boolean true or false. It has another method called intersect, unplural, that is going to go ahead and create the intersected geometry of two geometries for you. So let's go ahead and do that with polygons. If I draw a polygon here, and I draw a second polygon, and I go ahead and make the intersection. Don't worry about this. This is just the output from JSBin of the actual geometry here. And you can ignore the intersection point. That's because I'm going to show that next. But do these two geometries intersect? True. Yes, they do. And it's going to go ahead and console log out my geometry from where and add it to the map. All right, that's perfect. So let's go ahead and reset this. Now let's do the polyline. So I'm going to draw a polyline. I got one. And the second one. Okay, now here's where the issues come up. Do these two geometries intersect? True, and the intersection point is null. So you will not get a intersected point from two lines intersecting in this particular case. And if you look at the reason for that, and remember the geometry engine is essentially built off the geometry service, and you'll get the same results using the geometry service for the ArcGIS REST API. And if we look at the REST API here, and you'll see for the intersect method, the intersect operation is performed on a geometry service resource. This operation constructs the set theoretic intersection between an array of geometries and another geometry, right? So it's just basically, it's telling you it's going to do the intersection for two geometries for you. That's basically all it's saying. But the interesting part here is this. The dimension of each resultant geometry in the minimum dimension is the minimum dimension of the input geometry in the geometry's array and for the geometry specified by the geometry parameter. Okay, so what does that really mean? So the resultant geometry is the minimum dimension of the input geometry in the geometry's array, right? So that means that we're passing in a line. A line has a single dimension, one plane, right? So the minimum geometry you can get back from two intersecting lines is a line, meaning that the result you could get back, and I cannot draw straight enough to really demonstrate this on here, but if you were to draw a line like this and then try and draw another line directly on top of it, and like I said, I do not have the necessary skills to be able to draw an exact overlapping line there. That means that's the only result you can get back. Points have zero dimensions. They do not have a dimension. So you cannot get a zero dimension by measuring two singular dimension geometries. So I hope that's pretty clear. This kind of threw me off for a second, but then you have to go back to kind of, stuff you may have learned in school, you may have think about too often. But that's basically what this is telling you here. That if you do intersections of two lines, you can only get a result of a line. So you're not going to be able to get a point that way. So at first I thought this was pretty odd, but even looking at libraries like turf intersect will only do two polygons, right? And when you really think about the problem, what the issue really is, and then we'll clear this up here so you can kind of see where the problem comes into play. If I have a line here, that's one segment. And I draw here, that's another segment. And I draw here, now that's another segment, right? Okay, so if I draw another line, one segment, I have one intersection. I went over the same segment again, I have another intersection. I go over another segment again, another intersection. So I have 1, 2, 3 segments intersecting 1, 2 segments of this line, but not this segment. So to try and calculate the intersections of lines, the operation is going to grow exponentially based on the number of line segments you have, because now you're going to have to calculate this segment. Does it intersect with this segment, or this segment? Okay, yes or no, and then get the point. And does this segment intersect with this segment, or that segment? And it gets a result. And then you do this one here, this segment. Does it intersect with this one, or this one? Now in smaller operations that might not be a big deal, but you throw a large data set at this, like streets, utility networks, sewers, anything like that, and you can imagine how that operation can grow. So in desktop, there's a blog post from a couple years ago that actually about 2013, so about 3 years ago or so, almost 4 now, that describes this problem and the strategy to do it in desktop. And this kind of thing I've done before, and it basically boils down to dissolving your lines together, pulling out the vertices and extract the vertices for all of the line network, and then removing the endpoints, the vertices. So you can read through this blog post here. I'll put a link at the bottom of this video, and it kind of describes how you do this particular problem in desktop software. And I'm sure there's probably a similar workflow for this in QGIS. Now that doesn't mean all is lost. There is something you could do in the JavaScript API and using your web app. So there's a utility, if we're looking at 317 here, called Math Utils under Esri Geometry. Now what this Math Utils does is it has a method here called getLineIntersection. So getLineIntersection really only works on 2 line segments. So we talked about before, again, clear this up. I'm going to draw a line. That's one segment, that's one segment, and that's one segment. So the Math Utils method really only works on that calculation, that calculation, and that calculation. So you still have to do each line segment at a time. You cannot do multiple segments and run that. But again, you could set that up as a loop in your application and run it. But like I said before, that operation is going to grow based on the number of segments you have and the number of checks you have to do against each segment. So something like that might look like this. So I've got this simple little JS bin here, and let's go ahead and extract this out here a little bit. Let's go ahead and close the console on this one and make this a little bigger here. All right, so I'm basically going to get the start point and the end point for my first segment, and that's here. So I'm going into the paths and geometries, and I'm pulling out the beginning and end. And I'm going to get for the second segment as well, the start point and the end point for the second segment. And I'm going to start passing those in to the getLineIntersection method. And you also want to make sure that you pass in the spatial reference you're going to want the output for this to be. And when you get that, I'm going to go ahead and display it onto the map. So it's going to run this. I'll draw a line here, and I'll draw a line here, and there we go. I've got the intersection for those 2 lines and be able to display that point on the map. So you could run this operation on your own on multiple line segments on a small data set and pull out the intersection of each of those lines. But again, you're going to have to match each segment against every other segment that you want to check against. So it could take quite a while depending on the size of your data set to work with. And in the blog post, Christian gives a pretty good summary of the issue of trying to work with, extract geometry intersections and working with these dimensions and issues there. So look that over. Again, look over this blog post if you're interested to see how this particular problem is solved on desktop. And I'll put links to these JS bins in the notes for this particular video as well, and a link to this math details method that you could use. So hope that may help you out if you ever have to run into this issue or try and solve it on your own. Thank you.